The amount of water that's held within soil can influence the health of plants. Too little water and the roots can't extract it from the soil. Too much, and oxygen exchange becomes limited. When soil moisture levels start to decline, it might be time to irrigate. If they're staying high because of frequent rains or lower temperatures, it might be time to stop irrigating. Knowing how typical it is to have saturated or dry soils for a location can help with decisions about plant varieties and planting times. Such ambient soil moisture monitoring is what the State Climate Office of North Carolina has been doing as part of its EcoNet program for over a decade. A sensor is buried at each of our towers that measures the volumetric water content of the soil. The volumetric water content is the ratio of water-filled pore space to total available pore space. The State Climate Office of North Carolina takes measurements of volumetric water content every minute from a depth of 20 centimeters beneath the surface. We've done this at each of our EcoNet towers and have even set up sensors in an experimental site to monitor the soil moisture in organic soils. So what does this data look like? Shown here is a graph of volumetric water content recorded by sensors in an agricultural field in North Carolina's Piedmont in the summer of 2017. These are from an experiment scientists with the State Climate Office of North Carolina are carrying out to understand how land cover affects soil moisture. Two sensors were buried right next to one of our EcoNet towers, where we know the soil is a mixture of sand and clay. One sensor has been buried beneath bare soil, while the other sensor is underneath a cover of vegetation. Looking at the time series, we can see that the higher values, which are likely associated with saturated soils, tend to be around 0.4 or 40%, while the lowest values recorded are between 0.1 and 0.15 or 10 and 15%. If we compare the time series to precipitation measurements, shown in the blue lines and recorded by the EcoNet station's tipping bucket rain gauge, we can also observe that volumetric water content values tend to go up when there's precipitation and then slowly decline between events. There are also subtle differences between the measurements taken under bare soil compared to those with a cover of vegetation. The longer we go without precipitation, the lower the volumetric water content values beneath the vegetation become, likely because plant roots are extracting moisture from the soil. The daily uptake and nightly release of water by plants is also evident by the stair-step pattern in the vegetation time series. Soil cover and precipitation aren't the only factors that affect volumetric water content. Soil type is important as well. For example, clay soils have smaller pores and more total available pore space than sandy soils, so we would expect different volumetric water content values for each soil type under similar environmental conditions. You may notice these sorts of differences if you compare soil moisture values from across the state. Measurements like these are taken at each of our towers and can help with understanding typical values associated with saturated or dry soils. Whether our stations are in the mountains, Piedmont, or coastal plain, we maintain the full archive of soil moisture measurements along with a suite of other weather parameters. These are typically available to the public from our website 5 minutes after being measured at our stations. So check out our website, find the closest station to you, and see how our measurements compare to the conditions in your field.